Okay, in strain energy, we have discussed up till now definition of strain energy, models of resilience, proof resilience. Then we have discussed different cases to evaluate the stress condition. Say stress in a prismatic bar subjected to gradual load, stress in a prismatic bar subjected to suddenly applied load, and also we have discussed example based on that two condition. Now today we are going to discuss strain energy, stresses in a prismatic bar, stresses in a prismatic bar subjected to impact load. Fine. So this is the third case. Stress in prismatic bar subjected to just a minute. Subjected to impact. So this is our next theory. Okay, so today we are going to discuss stresses in a prismatic bar due to impact load. We are going to derive equation for a stress due to the impact load. Then after we are going to solve one example based on symptom. Okay, now for that purpose, let me consider a prismatic bar which is fixed at bottom. Okay, let us consider a prismatic bar which is fixed at bottom. So you can say this is a polar. ये bottom वाला part को आप polar बोल सकते हो. This is a technical term. Okay, it is a fixed at a bottom. Now let me mention here. This is a prismatic bar. Okay, we can say that suppose a force P which is suddenly applied, which is now we can say impact kind load. My question to all of you, we can say impact kind load is a one kind of the suddenly applied load. Can we say impact kind load is the one kind of the suddenly applied load?
Yes sir.
ऐसा हम बोल सकते हैं? Please reply me in chat box. There are 27 students. Please reply me in chat box. चलिए जल्दी जल्दी मेरे को चैट बॉक्स में जवाब दीजिए. मेरे को रीजन भी बताइए क्यों आप इम्पैक्ट लोड को सडन लोड बोल सकते हो. मेरे को रीजन चाहिए. यस नो में आंसर नहीं चाहिए. आई वांट आंसर विथ क्लू. Can we say, again I am repeating my question, can we say impact kind load, that is a type of the suddenly applied load? If you want to give me answer via mic rights, all of you having a mic rights, but give me answer one by one. Can we say impact kind load, that is a sudden load? First question is this. First thing first, चलिए आप लोगों ने यस तो बोल दिया, लेकिन उसका तो रीजन होगा ना. उसका रीजन दीजिए मेरे को. No, to make impact it should be sudden. That's okay, but why? इम्पैक्ट देने के लिए आपको सडन लोड अप्लाई करना पड़ेगा, एग्री हूं मैं, लेकिन व्हाई? नो, रॉन्ग. नाउ इन अ केस ऑफ ग्रेजुअल लोड वी हैव डिस्कस. चलो यस देव, यू आर राइट. फाइन. सपोज वी हैव थ्री कंडीशन: ग्रेजुअल लोडिंग, sudden loading, impact loading. In case of gradual loading, what we will do? We will increase load from 1 kilonewton, 2 kilonewton, 3 kilonewton to 100 kilonewton gradually. Yes or no? In case of sudden load, what we will do? We will apply 100 kilonewton load at the same time. And in case of the impact loading, what we will do? We will apply 100 kilonewton load at a time, but with some height h. Yes or no? So you can say impact load is a case of the sudden load, but sudden load is a case of impact load. Can I say sudden load is a case of the impact load? First question is that. No. Okay, so keep in mind this is a fundamental discussion. Okay, we are not here to only remembering the equation for gradual load, sudden load, or impact load, but this keep in mind this fundamental difference between different three different kind of the load. Fine. Chaliye. So we can say impact load is a one kind of the suddenly load. So actually we are apply sudden load, but at a some height h. इतना clear है? So we are suppose apply force P. मैंने force को ऐसे rectangle box में दिखाया हुआ है, ठीक है? For representation purpose only. Say this is your force P. Force equals to P. So we are what we will do, consider a prismatic bar fixed at a bottom end and let us assume that force P fall from a height h. Okay, ये आपका force है, h जितनी height से fall कर रहा है. Now this prismatic bar is the one kind of the elastic material. Is it clear? Because we are dealing in a elastic condition. Agree हो आप सब? पहले चलिए मेरे को ये बताइए, इतना clear है? So now what happened when your load is travel by amount h height? Okay, what will happen when your load is travel by amount h height? So your while traveling of this load h, can we say that at that condition your load is at this point? Yes or no? आपका लोड यहाँ पे आ जाएगा. So आपका मटेरियल ने h जितना तो ट्रैवल किया ही है, due to application of this load at a high, for a height h on a fixed end, your material also try to deflect. Yes or no? आपके मटेरियल में डिफॉर्मेशन होगा. Say that deformation is a delta L. Is it clear? Is it clear? So this traveling distance is a delta L. Now this is actually not only delta L, but if we are going to apply if we are going to plot a load versus deformation diagram, fine. If we are going to plot a load versus deformation diagram, it is a just kind of the suddenly applied load. Impact is a just kind of the suddenly applied load because we are going to apply a P load at the same time. As the application of load P, your material or your prismatic bar having a traveling distance h at the same time, and as the collision of the load on a polar, your material will travel further by delta L. Yes or no? So this is the traveling distance h due to application of the sudden load in form of the impact, and further traveling happen by amount delta L. Is it clear or not? Please confirm me. आपका लोड वर्सेस डिफॉर्मेशन डायग्राम सडन केस जैसा ही आएगा, लेकिन थोड़ा बहुत डिफरेंस है. क्लियर है स्टूडेंट्स? प्लीज कंफर्म इन चैट बॉक्स. दिस इज योर डिफॉर्मेशन and this is your load. I hope it is clear to all of you. चलिए fine. Now मैं theory term नहीं लिख रहा हूँ, चलेगा? I am not writing here any theory term. चलेगा? If you want to writing down, you can write while watching the recording. Okay? चलिए. So now we are interested to derive equation for stress as we have derived in previous two cases. So now amount of the work done in body, first of all. Amount of work done in body. First of all, for that we need a P delta diagram. Yes or no? Load acting just like a suddenly, and load first of all travel by distance h, and your material, so we can say that your material also travel by distance, and then after it will travel by amount of the delta L. Okay, so what is your work done? That is nothing but this diagram, P delta diagram. That is nothing but P multiplied by h plus delta L. Is it clear? Itna clear, students? Please confirm me. इतना क्लियर है? कितना क्लियर है? आपका वर्क डन कितना होगा? P इंटू एच प्लस डेल्टा एल। क्लियर? चलिए नाउ अगेन सेकंड हम क्या करते थे? स्ट्रेन एनर्जी कैलकुलेट करते थे, यस और नो? Strain energy, that is nothing but energy stored in a body, yes or no? Or energy absorbed by the body, yes or no? Strain energy, that is nothing but energy absorbed by body or energy stored in body. That should be calculated from area of R delta diagram, yes or no? We have already discussed what is R delta diagram. Area of resistance versus deformation diagram, R delta diagram. Now we are हम थोड़ा बहुत चेंज कर रहे हैं कैलकुलेशन की प्रोसीजर में। आपका आर डेल्टा डायग्राम तो ऐसा ही आएगा as we have discussed all three case, लेकिन we are not going to use this trigonometric area, but we can say that area of R delta diagram and now we can say that strain energy that is equals to work done, yes or no? We can say that your strain energy that is nothing but work done, yes or no? As we have discussed in previous lectures. बहुत ही केयरफुली सुनिए मैं क्या बोल रहा हूँ। इन प्रीवियस केसेस हमने क्या किया था? हमने यहाँ पे आर डेल्टा डायग्राम का एरिया कैलकुलेट किया था। वी हैव अ कैलकुलेट एरिया ऑफ आर डेल्टा डायग्राम। नाउ इन दिस केस वी आर नॉट गोइंग टू कैलकुलेट एरिया ऑफ आर डेल्टा डायग्राम, लेकिन हम फंडामेंटल कंसेप्ट यूज करते हैं। हमने फंडामेंटली क्या पढ़ा था? बाय एनर्जी कन्वर्जेशन लॉ से कि आपका वर्क डन है दैट इज इक्वल टू स्ट्रेन एनर्जी, यस और नो? एवरीबॉडी विथ मी प्लीज कंफर्म मी। आपका वर्क डन और स्ट्रेन एनर्जी इक्वल होगा, यस और नो? स्टूडेंट्स प्लीज बी एक्टिव इन चैट बॉक्स। फाइन। सो नाउ कैन आई से हियर this area of P delta diagram that is nothing but your work done and that is nothing but P into H plus delta L. इतना क्लियर है? We are not going to calculate any R delta diagram area in this case. Clear? Is it clear or not? Please confirm it. चलिए, all of you are knowing the equation of strain energy. What is the equation of strain energy? Now I am calculating this ये portion on next slide, so we will get proper space for calculation. Fine. So I am shifting to next slide. So strain energy that should be equals to P into H plus delta L. ऐसा हमने डिस्कस किया अभी तक। all of you know that equation of the strain energy that is nothing but sigma square by 2e, sigma square by 2e into volume that is equals to P into H plus delta L. Yes or no? Please confirm it, students. इतना क्लियर है? Can I write volume equals to area into length? Yes or no? Can I write volume equals to area into length and make a subject sigma square? Sigma square को मैं subject बना देता हूँ. So and take remaining thing on right side. So can I write like this and multiply this P inside the your bracket? So can I write like this? P. Can I write like this? 2e ph. ओके, मैं क्या कर रहा हूँ? ये 2e को सामने ले जा रहा हूँ, p को ब्रैकेट में मल्टीप्लाई कर रहा हूँ along with 2e. So can I write like this? 2e ph divided by volume, but can I write volume equals to area into length? Yes or no? Please confirm me, students. इतना क्लियर है? प्लस 2e p delta L divided by area into length. Yes or no, students? Please confirm me. Is this step is clear to all of you? ये step clear है आपको? फाइन. चलिए, now can I write just see here ये डेल्टा L into L, इसको मैं स्ट्रेन बोल सकता हूँ एंड E into स्ट्रेन, ये दोनों को मैं स्ट्रेस बोल सकता हूँ. यस और नो? यस और नो? क्लियर है? So I am writing same thing directly here. So can I say sigma square equals to 2e ph divided by area into length plus 2 into p by multiply by stress. Is it clear? Is it clear? Now question to all of you, can I write this P by A equals to stress? मैं ये P by A को स्ट्रेस लिख सकता हूं? मेरा क्वेश्चन ये है, सोच के आंसर दीजिए मेरे को. Read statement of the theory. Stresses in prismatic bar in due to subjected to. No, यहाँ पे मैक्सिमम मिनिमम जैसा कुछ नहीं आने वाला है. नाउ सपोज मैं P by A को स्ट्रेस कंसीडर कर रहा हूं तो आपका ग्रेजुअल कंडीशन हो जाएगा. यस और नो? यस और नो? मैं नॉर्मल स्ट्रेस कंसीडर करूंगा तो ये आपका ग्रेजुअल वाला कंडीशन हो जाएगा. सो वी आर नॉट गोइंग टू consider P by A equals to stress. हम इसको P by A ही रखेंगे. Is it clear? Don't make a mistake to consider P by A equals to stress. Stress वाला टर्म consider नहीं करना है because we are dealing with the impact load. ये लोड हमने कौन सा consider किया है? Tell me. ये लोड हमने कौन सा consider किया है? Impact वाला लोड है या gradual लोड है?
इम्पैक्ट लोड है.
इम्पैक्ट वाला लोड है. सपोज मैं यहाँ पे P by A को मैं स्ट्रेस कंसीडर कर रहा हूँ तो आपका ग्रेजुअल वाला कंडीशन हो जाएगा. सो डोंट कंसीडर दैट लोड P by A that is equal to stress. Okay, so keep in mind this thing. It is because it is important. Now what we will do next, सिग्मा वाले टर्म को एक साथ ले लेते हैं. तो कैन आई राइट लाइक दिस, सिग्मा स्क्वायर माइनस 2 P by A इंटू सिग्मा, थोड़ा मैं स्पेस रख रहा हूं यहाँ पे, दैट इज इक्वल टू 2E PH by L. इतना क्लियर है? इतना क्लियर है? कुछ नहीं किया है. 2P by A सिग्मा को मैंने लेफ्ट साइड ले गया हूं. ओके, वो टर्म को मैंने लेफ्ट साइड रखा हुआ है. चलिए फाइन. नाउ व्हाट वी विल डू, ऑन लेफ्ट साइड एंड राइट हैंड साइड वी विल ऐड P स्क्वायर बाय A स्क्वायर. क्लियर? P स्क्वायर बाय A स्क्वायर. मैं लेफ्ट साइड और राइट साइड दोनों साइड में P स्क्वायर बाय A स्क्वायर को मैं ऐड कर रहा हूं. तो मैंने एक्चुअली नलिफाई किया, ऐसा बोल सकते हो. जस्ट अ मिनट. ओके फाइन, क्लियर. सो नाउ कैन आई से दिस A minus B all square equals to A square minus 2AB plus B square. So can I say this is nothing but sigma minus P by A whole square? Yes or no? Yes or no? Compare like this. ऐसा बोल सकते हैं इसको? Please confirm me students. ऐसा बोल सकते हैं हम? So I am removing this thing and directly apply that fundamental concept. So can I write here sigma minus P by A whole square, that should be equals to 2EPH divided by AL plus P square by A square. Take square root of both sides, so we will get sigma minus P by A, that should be equal to square root of 2EPH divided by AL plus P square by A square. I hope it is clear to all of you. P by A को right hand side ले जाइए. So we will get stress equals to P by A plus square root of 2EPH divided by AL plus P square by A square. Yes or no? So this is an equation to calculate stress if your body is subjected to impact load. Is it clear? Stress for impact load. Now in this equation, if I am considering H equal to 0, in this equation, if I am considering H equal to 0, so can I say that sigma equals to P by A plus square root of, ये वाला टर्म तो 0 हो जाएगा, तो लिखता हूँ P square by A square. Square root of P square by A square, that is nothing but P by A. So can I say that stress equals to 2P by A? Yes or no? ये कौन सा कंडीशन आया है? ये कौन सा कंडीशन है? Tell me. Stress equal to P by A, ये कौन सा कंडीशन है? Sudden वाला कंडीशन है. This is a sudden load case. So that's the reason we have, before starting the theory, we have already mentioned that impact is a one kind of the sudden load, but sudden is not a case of the impact. Fine. So I hope it is clear to all of you. So you all have to remember this equation: sigma equal to P by plus square root of 2EPH by AL plus P square by S square. Fine. To calculate stress due to the impact load. Now, based on stress, you have to calculate further quantities. Now, so let me calculate one example. Please student, keep calculator with you. Example based on impact. Chali. Let me writing down data. A 1500 mm long wire of 25 mm square area is hanged vertically. It receives a sliding collar 100 Newton weight and top at bottom. The collar is allocated to fall on a stopper. Through 200 mm हाई. ओके, आपका लोड है वो 200 mm की हाइट से फॉल हो रहा है, ऐसा बोला हुआ है. डिटरमाइन इंस्टेंटेनियस स्ट्रेस induced in a wire and corresponding elongation. Also determine strain energy stored in a wire. Consider E equals to 200 gigapascal. This data is clear to all of you? Please confirm, students. Data clear है? Data पढ़ के ऐसा पता, can you able to judge it is a case of the impact load? ओके, आपको पता चलना चाहिए कि ये इम्पैक्ट वाला कंडीशन है. फाइन, आपको पता चलना चाहिए. चलिए, once you are able to decide your case is an impact condition, then your calculation work will be very simplest. Right? So now, first of all, we are writing the equation of the stress due to the impact load. अपना इक्वेशन क्या है? Stress equals to P by A plus square root. Now, हमने यहाँ पे इक्वेशन को रीअरेंज नहीं किया था. ओके, सो लेट मी फर्स्ट रीअरेंज आवर इक्वेशन सो इट विल बी इजी टू रिमेम्बर. ओके, हम इक्वेशन को थोड़ा रीअरेंज कर देते हैं. ओके, वी आर that is a technical term. Yes, okay, technical term. So stress equals to P by plus square root of P by A plus 2E PH by AL. Okay, so now we will remember this equation like this, so it will become easily to remember equation. Fine, chaliye. So let me first of all write a equation of the stress due to the impact load, that is P by A, square root of P by A plus 2 E PH divided by AL. Now चलिए, आप स्केच ड्रॉ करोगे तो भी चलेगा, नहीं करोगे तो भी चलेगा, डिपेंडिंग ऑन ऐसा कुछ सिस्टम दिया हुआ है फॉर एन एग्जांपल. Okay, suppose length of the wire is of 1500 mm. फाइन, एरिया दिया हुआ है 25 mm स्क्वायर, सो यहाँ पे हम लिखते हैं L इक्वल्स टू 1500 mm. क्रॉस सेक्शनल एरिया दिया हुआ है A 25 mm square. So in this equation we have a area, yes, we have a length, yes. आपके पास एरिया अवेलेबल है, लेंथ अवेलेबल है. चलिए, hang vertically, it receives a sliding collar. Sliding collar is nothing but one kind of the load. Okay, one student is asking me what is a collar. That is nothing but technical word to apply the impact load. Okay, just search a Google, you will get a information regarding sliding collar. I am not going to discuss what is a collar in detail. Clear? So please search it, you will get that information. Okay, that is a simple one kind of the loading. Sliding load हम apply कर रहे हैं ऐसा बोल रहा है, लेकिन हम एक पर्टिकुलर पॉइंट से उसको में हम ड्रॉप कर रहे हैं. उसका वेट कितना है, P इक्वल्स टू 100 न्यूटन दिया हुआ है डेटा में. स्टॉप एट अ बॉटम एंड, यहाँ पे ये स्टॉप हो जाएगा, स्लाइड हो रहा है, लेकिन कब अप टू विच डिस्टेंस वो ट्रैवल होगा, अप टू एंड. फाइन, नाउ द collar is allocated to fall on a stopper. This is your stopper through a 200 mm height. So ये आपका हाइट 200 mm है. I hope it is clear to all of you. H equals to 200 mm. Okay, so आपके पास H भी अवेलेबल है. डिटरमाइन इंस्टेंटेनियस स्ट्रेस इंड्यूस्ड इन अ वायर. नाउ आपको स्ट्रेस कैलकुलेट करना है, लेकिन बेस्ड ऑन अ गिवन लोड कंडीशन. एज पर डेटा, लोड कंडीशन इज अ इम्पैक्ट लोड. दैट्स द रीजन वी आर गोइंग टू अप्लाई दिस इक्वेशन. Okay, this is nothing but a stress, instantaneous stress developed due to the impact loading. Fine. So first of all, you have to calculate stress. Now all people can able to calculate stress, yes or no? आपके पास सब डेटा अवेलेबल है?
Yes sir.
So please calculate stress and give me answer. चलिए, स्ट्रेस कैलकुलेट कीजिए और मेरे को आंसर दीजिए. डेटा में E का वैल्यू दिया हुआ है, E इक्वल्स टू 200 गीगापास्कल.
200 GPa.
So now we are interested to convert into Newton per mm square. So can I write like this, 200 into 10 raised to 3 Newton per mm square? Yes or no? ऐसा कुछ?
Yes sir.
Yes sir.
So if you don't remember relation, please Google it. You will get all the relation. Fine. So we are not going to wasting our time for how to convert unit conversion. Fine. चलिए. So we have E also. H भी हमारे पास available है. H equals to 200 mm. So let me put all the value one by one. Sigma equals to, चलिए यहाँ पे हम P भी लिख देते हैं. P equals to what is unit? Unit भी बताइए मेरे को. P equals to आपका 100 है, एरिया दिया हुआ है 25 प्लस.
Yes sir. 100.
यहाँ पे स्क्वायर आएगा, किसी ने बोला नहीं. 100 square
100
by
square
25
upon
square.
25 square.
Please, I am writing here. Don't. Plus
Sorry,
2
sorry.
into, no problem. E equals to 200 into 10 raised to 3. P अवेलेबल है हमारे पास. P equals to 100 H equals to 200 divided by area again 25. Length is 1500 mm, 1500 mm. Clear? So please calculate term by term and add it. Okay, if you are going to calculate it, you will get 100 by 25, that is a 4, plus square root of ये वाला टर्म आएगा 16 if I am not wrong, प्लस दूसरा वाला टर्म आएगा 21333.33. क्लियर है? ऐसा कुछ आ रहा है. सो वी विल गेट सिग्मा इक्वल्स टू, सम कीजिए, स्क्वायर रूट निकालिए, यू विल गेट सिग्मा इक्वल्स टू 465.89 न्यूटन पर mm स्क्वायर. आई होप इट इज क्लियर टू ऑल ऑफ यू. क्लियर है ना? चलिए फाइन. स्ट्रेस है, स्ट्रेस का यूनिट न्यूटन पर mm स्क्वायर रहेगा. Now second thing, you have to calculate corresponding elongation. So we are interested to calculate elongation. चलिए elongation यानी कि elongation किसको बोलोगे आप? चलिए बताइए पहले मेरे को. What is elongation?
Change in length.
Yes. So just see previous. I am not going to draw second sketch. You have to calculate this delta L. Okay. आपका कॉलर यहाँ तक आएगा, तब जितना चेंज इन लेंथ होगा वो आपको कैलकुलेट करना है. दिस इज योर स्टॉपर कॉलर सिस्टम. ऐसा भी आप इसको कंसीडर कर सकते हो. ठीक है, चलिए. सो वी आर इंटरेस्टेड टू कैलकुलेट डेल्टा एल. सो नाउ वी डोंट हैव एनी स्पेसिफिक इक्वेशन, डायरेक्टली इक्वेशन फॉर डेल्टा एल, बट वी ऑल नो स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू स्ट्रेन. ओके, I have discussed this terminology lots many times. So can we say that stress equals to modulus of elasticity into strain? Because जितने इक्वेशन कम याद रखोगे वो अच्छा रहेगा. Yes, you are right, Dev. Your answer is right. 3.49. Okay, so we have equation of the strain. Strain हमारे पास अवेलेबल नहीं है, लेकिन strain का इक्वेशन हम बना सकते हैं. सिग्मा इक्वल्स टू E into delta L by L. So subject delta L, you will get sigma into L by E. Yes or no? Students, इतना क्लियर है? हमने स्ट्रेस कैलकुलेट करके रखा हुआ है. प्लीज taking in consideration, don't consider sigma equals to P by. If you are going to consider sigma equal to P by, that is the case of the gradual condition. Yes or no? But we are here interested to calculate elongation for a impact condition. So don't make such a mistake. Fine. So take a sigma whatever you have calculated based on impact condition. So let us put all the value. We have already calculated stress, that is nothing but 465.89 multiplied by length divided by E. Length आपके पास अवेलेबल है 1500 mm. करिए मल्टीप्लाई 1500 mm से. E हमारे पास अवेलेबल है 200 into 10⁻³ टेल मी कितना डेल्टा एल आएगा? यस, 3.49 mm. आई होप इट इज क्लियर टू ऑल ऑफ यू. आई होप इट इज क्लियर टू ऑल ऑफ यू. चलिए फैंटास्टिक. नेक्स्ट व्हाट वी विल डू in data, also mention that calculate strain energy stored in wire. So you all people knowing the equation of strain energy, that is equals to sigma square by 2E into volume. Yes or no? Yes or no? So sigma square by 2E into volume. ऐसा कुछ इक्वेशन हमारे पास अवेलेबल है. Again put all the value. Sigma equals to 465.89 square divided by 2 into 200 into 10⁻³ multiply by volume. You have already actually volume is directly not given, but we can write volume equal to area into length. 20.1500. 25 multiply by 1500. Please tell me what is the value of the strain energy. कितना वैल्यू आएगा बताइए. Yes, right. So we can write like this: 20348.76 Newton mm. हमारा इनिशियल आंसर न्यूटन में आएगा, इतना लंबा आंसर नहीं लिखना है तो ऐसा भी लिख सकते हैं, स्ट्रेन एनर्जी U इक्वल टू 203.48 किलो न्यूटन mm. यस और नो, दैट डिपेंड्स ऑन यू। ऐसा भी आप लिख सकते हो, और आप ऐसा भी लिख सकते हो 203.48 into 10⁻³ Newton mm. Depend on you, depending on you. Is it clear or not? Please confirm, students. इतना clear है? इतना clear है?
Yes, sir.
Okay. So, is there any question in today's lecture? Tell me. Is there any question in today's lecture? Right. Chali. So, we are going to stop today's lecture. Just a minute, students. Don't leave the room, because there is some announcement for you.